Hey gang, Professor Feezer here, and today we're going to take a look at Wireshark, specifically the SIP protocol. This is an example of a call setup and teardown. If you're not familiar, Wireshark is the industry standard for not just capturing, but viewing, primarily viewing network traffic in the form of files called PCAPs or PCAP Next Generations. It can be used by any IT or network professional, heavily used by telecom. If two phones aren't ringing, you have to have packets in order to figure out what's going wrong. At this point, all phone is supported by SIP or a protocol called WebRTC, but this is SIP. SIP doesn't have voice and video within it. That's done with another protocol called RTP. It would be a companion protocol. I have that filtered out. The SIP itself is just the signaling portion. So, hey, I want you to start ringing. Other phone says, hey, I'm ringing. Other phone says, hey, somebody picked up. Now we can begin the RTP exchange. And then signaling would handle the somebody hung up. Okay, I understand. Let's tear down the session. I'm going to go step by step through this trace as if we were analyzing it for fault. Although there is no fault in this call. We're looking at a basic example, telecom example between two phones. When you open Wireshark, you usually get these three sections. So up top is packet list. This is packet details. And this is packet bytes. Packet bytes isn't going to be very useful to us. So to save some screen real estate, you can go up to View and just turn off packet bytes. Next, I see invite. I see 100, 180, PRACK. Up top, there's a bunch of different messages. Now, in the case of this invite, it's the same invite. It's just hopping between different places. Here it goes between 192.168.32.1 to 192.168.203. And then to 192.168.203 to 192.168.12.1. So it's making hops. If I want to see it, I just click on it. And then the details become available to me. These are broken down by layer. So this would be MAC address, layer 2, IP address, layer 3, ports, layer 4. Right there, SIP is actually layer 7. So we're hopping up to a layer 7 application layer protocol there. I'm not really going to get much out of opening these underlying protocols. I really just need to open SIP. There you can see the start line or the request line. That's actually what's displayed in the info right there. If you look here, that line, SIP 1101 at IP address, that's the same thing that's right there. The message headers contain the actual headers that control signaling details. And the message body, in this case, controls or is carrying SDP, Session Description Protocol, which is set up meta information for the RTP, which I told you will exchange the voice and video. So this is set up, looks like, for an audio call. I can click on the next packet. Again, no reason to open the lower layers. If you do, say open UDP, you don't get any more information. You know, the useful information's right there, from UDP, source port 5060 to destination 5060. I don't see anything else that would help me understand what's happening. I hope you're enjoying the videos so far. I've been a telecom consultant and educator for about the last 15 years. This picture was taken by one of my students just a few years ago at one of the big 3 cell phone providers here in the United States, as I was lecturing about how SIP can use 4G to access an IMS core. If you need to learn more about SIP, 4G, 5G, the IMS, anything about telecom, either for yourself or a group of individuals, I have guaranteed to run classes. We can also schedule a class either on-site or online. I'm going to put a URI down in the comments that you can click on to learn more about those offerings. So this represents a call going out. In the SIP world, we understand that 1101 is the call digits. At 192.168.200.3 is what we think the next is the next hop. That could get transformed. That's just it going in, or it going from 32.1 to 200.3. That could certainly change. It must when we click on the next one because it's going to 12.1. See how it changed? We're not going to go crazy into the details of SIP routing here. I'm just showing you, some supporting information. Invites hopping very quickly between SIP back-to-back UAs is what they are. They're Cisco back-to-back UAs. The 100 coming back is a polite message back. It means, hey, I received your invite. All of this stuff is being done over UDP. UDP has no sense of reliability built into it. So it's at a higher level, up at this SIP layer, that we're forced to provide mechanisms similar to what, say, TCP might have provided us if we were down at layer 4. SIP can run over TCP, but it can also run over UDP. So they had to build in this assumption it was going to be over UDP. The 100 really doesn't do anything. It's just a message back saying, don't retransmit. I got this. The invite's hopping between SIP devices. Each one's just firing back this 100 that says, okay, we got the invite. The 180 is actually generated by Bob. So Alice sends the invite. Bob sends this 180 coming back. It means his state has changed from on hook to ringing. That's a ringing message. And it's going to take the exact same path back to get to Alice. This PRACK, let's ignore this for now. I'm right-clicking these. I'm ignoring these messages. They'll just confuse us right now. The 200 is when Bob picks up. So this represents Bob picking up, and the message takes the same route as the 180. The difference here, the 180 tells Alice, the person who made the call, it's okay for her to start playing normal ringback. So when Alice is here, she hears silence until she receives that 180. Now you might think, oh my goodness, that's peculiar. She's going to hear silence for a long time. Well, not really. 0.06 seconds is how long silence is there until a ringback begins. So no time at all. The 200, it looks like 10 seconds of ringing until somebody picks up. That's Bob pickup. So Bob sends the 180. Bob sent this 200 that picked up. And it's even, Wireshark's even telling us, hey, the 200, the pickup indicator is to the invite. You sent this invite. Hey, somebody picked up your invite. The ACK is sent instantaneously upon receipt of a 200 by Alice. Again, this has to do with reliability. I mentioned this is over UDP. There's no reliability at the UDP layer, or potentially over UDP. There's no reliability there, so the ACK just indicates we got the 200. You only send an ACK if you send an invite. It's just how the protocol works. You send an invite, you're on the hook to send an ACK eventually, even if it doesn't work. In this case, it did. Somebody picked up. Now, the delta between when we send the ACK and the buy, not a long phone call, but it was a test call. I can right-click that and set time reference. That marks that as reference 0. So if that represents the start of talking, 3 seconds we talked for before a buy is generated. Now you can notice the invite is sent to 1101, that's the extension. The ACK is sent to 1101, that's the extension. So that's Bob's extension. That's Alice calling Bob. That's Alice on the hook to send the ACK. The buy is being sent to 1301. That must be Alice. We could figure that out if we dug into the headers, but we don't care to. It's just a quick glance through the looking glass, as it were, at a Wireshark capture, a SIP capture. So what can we infer from that? Well, if it's going to Alice, Bob hung up first. 3 seconds on the call. Maybe he heard Alice's voice and says, oh my gosh, I gotta go. That buy is sent a 200 back, and that's it. There's no ACK. I told you, invite, once the invite is received, you send an ACK, or once the invite fails, you still send an ACK, but that's the only case. You don't send an ACK otherwise. I had mentioned a moment ago there was some additional packets that we might have found confusing. Well, let me throw a scenario at you. Suppose this 180 was lost. I'm going to right-click it and ignore it. As in, it was sent, but the network dropped it. It's not a possibility, but it is UDP, so it could disappear. There's no reliability built into it. In that case, Alice hears silence. Alice sends an invite, and if she holds that phone to her ear for long enough, for 10 seconds, somebody does pick up eventually, but there's no indicator that Alice should start playing ringback. So that 180 is actually really important to get from Bob back to Alice. We want Alice to start hearing ringback. The problem is there's no reliability built into it. So that's what this is about. If you can imagine, our goal is to make the 180 reliable. Bob sends this. As proof that Alice received it, she sends a PRACK back, a provisional acknowledgement. It's not an ACK, it's not an acknowledgement, it's provisional acknowledgement. Bob echoes back with a 200 to the PRACK. It's a three-way handshake. Bob says, hey, start your phone ringing. Alice goes, yeah, okay, I'm playing ringback. Bob says, great, thanks for telling me you're playing ringback. This 200 then is Bob picking up the phone. That's a human doing something. That's the purpose of the PRACK. It's a three-way handshake that ultimately makes a potentially unreliable protocol reliable, specifically the instruction for Alice to hear a ringback. Thanks so much for tuning in. I hope you learned something about Wireshark and SIP. If you did, go ahead and hit subscribe, and I'll see you in the next video.